Bienvenidos, Ushamandid, and welcome UMGC learners from the CMIT-455 Section 6380 course for the spring 2021 semester. This is the CCNP ENCOR version 8 course curriculum from the Cisco Networking Academy, and in this activity, we're going to be taking a look at Packet Tracer 26.2.1, where we're going to be working with extended IPv4 ACLs. And this is the first of two scenarios in which we'll be working with extended ACLs. So let's go ahead and dive in and take a look at the topology that we'll be working with here. And one of the first things I want to point out is, remember, ACLs, or access control lists, are not stateful. In other words, an ACL is not keeping some sort of state table information regarding source and destination IPs and port numbers. It is literally checking every packet, looking at whatever information it's supposed to be looking at as that packet either ingresses or egresses, enters or exits from the interface in question. And so here's our topology, and let's go ahead and dive in. So the scenario is we've got two employees need access to services provided by PC1, or provided by the server. PC1 only needs FTP access, while PC2 only needs webcam access. Both computers need to be able to ping the server, but not each other. And so this is a nice activity. It's going to give us a soft landing here into extended ACLs. And the majority of our time is going to be spent here on router 1 doing our configuration. So let's give ourselves a little bit more room with which to work. And let's dive in. So from global config mode, again, we go from user exec into global config with the enable command. And then we're going to type in access, get into global config, and we're going to type access list followed by, excuse me, the question mark. Now we can see here in Packet Tracer that we see that there are two ranges of standard ACLs and extended ACLs, or two different ranges, right? And the standard access list range is from 1 to 99. The extended access list range is from 100 to 199. Now, what we don't see in Packet Tracer that we're going to see here on a real Cisco switch is that when working with access lists, there are actually expanded ranges that you can work with. So if I was to say access list here on a real Cisco switch running 15.x code, you can see that not only do we have the standard access list and extended access list ranges that we see in Packet Tracer, but we have expanded ranges as well. In other words, the use case here is either you don't want to use 1 through 99 or 100 to 199 for the respective access list type, or you've exhausted all of the available ACL numbers for the respective range in the standard or extended access list range here. So what you could do is you could come out here and use these expanded ranges. And so for a standard ACL, it would be 1300 to 1999. And for an extended access list in the expanded range, it would be 2000 to 2699. And so again, I just want to touch on that because Packet Tracer, again, gives us the ability to do standard and extended ACLs, but we're only seeing what would be considered sort of the regular or normal range of values. And there are expanded ranges of values. So I'm going to say access list 100, and we know that that is in the extended ACL range. So now the question is, what are we going to do? Are we going to deny? Are we going to permit things? Or are we going to put a remark? And a remark is simply a comment that we can enter in that might give a little more context as to what this ACL is to be used for. And on numbered ACLs, this is a great idea. Remember, we can have numbered ACLs, which is what we're looking at here. You can also have named ACLs, where we can give it a descriptive name. So with a numbered ACL, somebody might not know what ACL 54 is actually doing, or when it was created, or who created it, or why it was created. And that's where the remark becomes important. And so we're going to be permitting FTP traffic here is what we're doing right out of the gate. So I'm going to say permit. And if I do a question mark, you can see permit what? We've got all of these different protocols here that we can work with. Now, of special note is the IP protocol. And you have to comment on this when talking about creating extended ACLs, because when you specify, like if I was to say access list 100 permit IP, IP is all protocol. So it's literally like you're saying access list 100 permit all when you say access list 100 permit IP, and the all applying to the protocols. So in other words, when I say IP, I'm saying all protocols that are listed here, I'm going to permit with this ACL, right? In this context here. So remember that. That's not very granular, right? If I'm allowing all protocols to come through, typically with an ACL, we only want to allow specific protocols. And here we're talking about TCP, right? The Transmission Control Protocol. And we're going to go down to a more granular level here as we continue to work. So, but FTP leverages the TCP protocol. If I was trying to match Telnet, I would be saying permit TCP. If I was trying to permit HTTP or HTTPS, I would be saying permit TCP, right? And so now we get down to the source. Remember, the source always gets listed first here when we're working with ACL. So it's access list 100 permit TCP from who, right? From where? What source? And so in the scenario, and again, as I'm kind of like sliding through here to keep you up to date with where we're at in the activity, on step E, it's really telling me that this is going to be the source, right? And you could say, if you were going to list it for a specific host, you could put in here host followed by the IP address of the host. Or you could say, I could list out the source address and then the subnet mask, the wildcard mask, which is the inverse of the subnet mask, which is typically what you're going to be tested on. Or if I'm just saying that anybody, right? Again, not too granular to say, yeah, permit TCP from anybody, right? We want to be more granular here. And so it's going to be the 172.22.34.64 network. And again, we can specify the entire network as well. And so it's coming off of this interface here, this gig 00 interface on router 1. This is where that 172.22.34.64 network lives. Now, let me show you the multiple ways that we could do this. I could say host 172.22.34.66. That is totally legit. And if the only host that needs FTP access, right, which is what we're configuring here, going to the server is that host, then this is a legitimate way to do it. In fact, this is typically what you'll see done, because in a security context, we want to be providing access on sort of a least access, right? We want to configure the most restrictive access we can initially, and when that's possible, that's what you would do. So I could say host 172.22.34.66. What I could also say, if I didn't use the host keyword, is 172.22.34.66, and then I could put a subnet mask in here. Or, I'm sorry, I keep saying subnet mask, a wildcard mask in here. So I could say 0.0.0.0. So like that statement right there, the 172.22.34.66 with quad zeros, is equivalent to saying host 172.22.34.66, right? So you might see it in both syntaxes. Now, they want us to set it up for the entire network, right? Obviously, they're going to force the issue of us having to figure out what the wildcard mask is going to be here. So we're going to say 172.22.34.64. We're putting the network ID, the subnet ID, because we want this to apply to everybody in this subnet, because maybe we're going to add some hosts onto switch 1 who are going to be possibly connecting through via FTP through router 1 up to the server. So now we get to the portion of the activity where they talk about calculating what the wildcard mask value is going to be. Now, they do this bitwise operation here by breaking the wildcard mask, or breaking the subnet mask, into binary. And that's what you see here with the 255, 255, 255, 224 for that CIDR notation /27. And then they basically list out what the value would be in binary for what the subnet mask will be by simply doing the reverse, right? The inverse of the binary representation. Now, there's an easier way to do this instead of writing it out in binary. And again, writing it out in binary is totally legitimate. This is a great way to learn how to do this. But you might also notice something funny here at the end. So 224 plus 31. So in the wildcard mask, we're turning on the host bits that are not being used in the dotted decimal binary version of the subnet mask. And so that's why they refer to it as the inverse. And so 31 plus 224 would be 255. So the way that I like to approach this, and we'll give you a different way to do this, is to simply subtract the subnet mask in dotted decimal notation from all 255s. Would that not give you the exact same wildcard mask value? And it would, because 255 minus 255 is 0. 255 minus 255 is 0. 255 minus 255 is 0. And then 255 minus 224 is 31. So instead of writing it out in binary, you can kind of do the math in your head. If you know the dotted decimal subnet mask value, and again, here we're dealing with the last octet only, all you would have to do is say 224 plus what is 255? And then you look at that and you're like, oh yeah, 31. There's my wildcard mask value, 00031. So let's drop that value in here. 0.0.0.31, and and then we'll do a question mark, right? Because we've taken care of the source side of things here. And you can see, and again, it gives you a nice little write-up in here of the destination host, what any does, equal, greater than, host, less than, ports not given a port number, or I'm sorry, packets not given a port number, and then a range of port numbers, if you will. So now we're going to configure the destination. So we're going to permit the TCP protocol, all applications that are using the TCP protocol from this subnet, this network subnet range here, the 64, and we're going to allow it to go to the destination specifically. Here now, they decide we're going to say host. And again, this makes sense based on the explanation that it's only to the server. And so I'm going to say host 172.22.34.62. Now, again, that's equivalent. This host 172.22.43.62, I'm sorry, and I just realized that would have caused all kinds of issues later on, 34.62, that's equivalent to saying 172.22.34.62 quad zeros. But again, I'm a huge fan of the keyword host because it makes it so much easier to read what you have in front of you, right? So now that we get there, let's do a question mark. And so for the destination, the question is, what ports are we going to be allowing? And I'll bring it right up to there, which is where we're at. And again, equal to what? So I'm allowing all TCP traffic from this subnet, and ultimately we're going to be applying things here on gig 00, I believe, is the interface that we should be placing it, and that's probably what it's going to be. But all TCP traffic from all hosts on that subnet are allowed to go to this host, But this host is only interested in allowing those connections if the port number or the service is equal to FTP. And so again, when we apply that ACL on this interface, yeah, we're allowing all TCP traffic from all hosts on this subnet to go through that interface, right? To go into this interface and to be allowed in if they are going to that host and the destination port number represents FTP 21, right? Port 21. And so that's the decision that will be made for every packet that hits this interface right here, gig 00 on router 1. And so we're going to create a second ACL entry, an access control entry, or ACE as they're commonly referred to. And it says create a second access list to permit ICMP traffic, right? And then all other traffic is going to be denied. And so what I can do is I can save myself some time, hit the up arrow, right? And since it's going to be the exact same ACL with the exception of the protocol ICMP, right? So we're going to be accepting all ICMP packet types from that subnet that are going to that exact host address. We're not checking to see if it's going to a specific port on that host, just any ICMP packets that are going to that IP address are also going to be allowed in. And so we'll hit enter and you can see the activity bumped us to 40%. All other traffic is denied by default. And this is one of the more common mistakes that learners make, especially when they're expecting, or they have a couple deny statements at the beginning, or let's say it's just 2 deny statements instead of permit, and then they forget to permit everything else. At the end of every ACL, whether that ACL is a standard ACL or an extended ACL, at the end of every ACL is an implicit deny any, right? And so what we have implicitly, you don't have to enter this in, right? And this is what we've got. We've got, for an extended ACL, it's going to be deny IP any. Because remember, we said IP matches everything. So that is an entry. Again, you don't have to type this in. It's there by default. It's implied that if I don't permit traffic, that traffic is going to be denied. And in the standard ACL, it would just be, deny any. So keep that in mind when you're creating your ACLs, especially when you're being asked initially to deny some things and then permit everything else, right? Remember, you have to come in there and say, hey, permit IP any, if that's what you're going to do, okay? All right, so now we're going to go ahead and execute the show access list command. Let's bump out of here. Let me save the config and we'll say show access lists. And so there is our ACL 100 and we're permitting TCP traffic for all TCP traffic and all applications that are using TCP to go out to that host right there, but only if that's the destination and that's the port number that they're going to, 21. And then we're permitting ICMP out from everybody going to that host, right? Okay, so the next thing we've got here is we're going to be applying the ACL. Remember, with an extended ACL, Cisco best practice is to get that ACL as close to the source as possible. With a standard ACL, we want to get it as close to the destination as possible. And so here, where's my source at? My source is PC1. PC1 is going to be generating all this traffic. That is why we place it here on gig 00 and not up here on gig 02. So, whoops, we've got router 1 open up here. Let's go ahead and get into global config. We'll say interface gigabit Ethernet 00. And to apply the ACL, I'm going to say, and actually before we apply the ACL, let's do some quick testing here. Let's see if I can ping PC2. So I'll say ping 172.22.34.98. Again, simply creating the ACL on the router does not apply the ACL. And that's another important point. So we've got this ACL here, right? So what is it doing right now? Yeah, it's doing absolutely nothing. Me creating an ACL, irrespective of how many access control entries or ACEs are in that ACL, until I apply that ACL to either a physical interface or a virtual terminal line, VTY interface, it is not being used. It's just sitting there, right? So keep that in mind as well. And you can see, can I ping the host PC2? All right, let's check and make sure that we can ping the server with a 172.22.34.62 IP. Can I ping that right now? Because we want to make sure that if something breaks, we understand why it's being broken. And I can. So everything is working great. Now remember, once I apply this ACL to gig00 IP access group, and then here's where you put either the name, if it's a named ACL, or the number for a numbered ACL, which is what we have. And most importantly, in which direction do you want the traffic to be inspected? And this is one of the more confusing things for learners, right? So we're putting the ACL here on this interface. And the question is, the way that this ACL is created, here is my source information. So the ACL is going to be looking to see, is this where the traffic is coming from? Right, so we'll say this is where is the traffic coming from these networks. And here, we'll draw a line down here. Here is the destination information that this ACL is going to be checking in the IP packets, right? It's going to be looking to match the IP addresses and the TCP and ICMP port numbers. It's going to be looking at that information to see, does it match? So the question is, would this ACL as written match return traffic coming from that IP address? And the answer is no, because remember, this is the source information. So if we place the ACL here and I put it in the outbound direction, again, meaning egress from the router, on this interface, and I'm inspecting traffic and this is what I'm trying to match, it's not going to work because the router is going to look at that traffic and say, that is my source address. Here is my destination address. In other words, this ACL would need to be reversed in order for it to be effective if we placed it here and put the outbound direction. In fact, let's test that. And this is easy enough to test. So we put it here and we say in the outbound direction. And so now let me see if I can ping. Oh, whoops, didn't want to do that. We'll do Control C. Now let's see what happens when I try to ping. And we'll just hit the up arrow. So can I ping the server? And the answer is no, I'm not able to ping the server because now there's an ACL here. Remember, it's looking at every single packet that is coming out of this interface. And it's looking to see, does it match one of these two statements? Because those are the only statements permitting traffic. So if traffic doesn't match those statements, it's not going to be allowed. And that's all traffic is being examined, right? So the reason it's not matching and the reason that we can't ping anymore is because the return traffic here, when it gets to that interface, that gig00 interface right there, it wants to come out this way, but the router says, Well, I'm looking at where it should be coming from, and that's not where it's coming from. It's coming from here. This is the value for the source from where the traffic is coming, and this is the only traffic I'm allowing out in my ACL, or the destination I'm allowing to go to. This would be the source, not the destination. This would be the destination. And so that ACL, that last implied entry that's down in here, deny IP any. It's not allowing any traffic through. In fact, let me come over to PC2, and we didn't want the terminal. Let's stretch this out, give ourselves some more room with which to work. Can I ping 172.22.34.66? And my question to you is, in this ping packet, this ICMP packet that we're going to be sending, the source is 172.22.34.98. It's not in this network. That ACL is only going to be allowing traffic out if this is the source, right? It's not going to work. So we get destination host unreachable. And this is the router telling me that, yeah, we've got some kind of a problem here, because I don't even know how to get to that destination. It's being blocked. Oops, sorry, I was trying to move that. It's being blocked. So destination unreachable, we've applied it in the wrong direction. Let's now go in and let's fix this. So let's get back into global config. Let's go into int gig 00, and let's say no IP access group 100 out. And again, we're still at 40%, but that's a very important thing to understand, is the way the ACL is written and the order of the source and destination in that access control entry is critical and inextricably linked to the directionality of how you apply the ACL to an interface. So now we're going to say IP access group 100 in. In other words, the router 1 is now inspecting all traffic that is coming inbound to the gig 00 interface, which would mean it would have to be and can only be traffic literally coming off that switch link right, or the switch port right here, coming to the router. So even if I put another PC out here and another PC over here, all of their traffic is going to be examined on that port as it comes inbound, and it's going to be compared to the ACL we have configured, which do show access list ACL 100, and it's going to check to see, hey, first of all, is the source coming off of that network, right? Okay, well, and is it TCP and ICMP traffic? And if it is, I'm only going to let the TCP traffic go if it's trying to establish an FTP connection to that host, and I'm only going to let the ICMP traffic go if it's trying to send to that host, which again, same host, server, but you get the point, right? That is what the router is doing. The router is not keeping track of, in terms of a stateful table, like some live stock market update that takes place during the trading day, right? It's not tracking any of that, okay? It's simply looking at every single packet as it enters the interface, and it's making a decision. Does it match one of my access control entries that I have here that say permit? If yes, then let the traffic continue on. Route that traffic out the interface it's supposed to go out. If no, if the traffic doesn't match, then I drop that traffic. So we've got it applied now, and you can see here, they're asking us to go ahead and check and verify the implementation. Can we FTP over to the 172.22.34.62? Can we FTP to the web server? Take a look at that. Looks great. And again, I don't know what the username is. Cisco. And well, I think I put the wrong information in there. Cisco, I thought I put it in, right? CISCO. There we go. All right. So we can FTP in there, right? So it's it's working beautifully. Quit. There we go. So it's working beautifully. All right. So now what we're going to do is we're going to move on to part number 2. Excuse me. We're going to configure and apply and verify an extended named ACL. Now, one last thing I want to touch on before we move on actually is with the router here. If I say show access list now, we can actually see how many packets have been matched, right? So it's always a good thing to go back in, take a look and see whether or not the ACL is matching or if it's hitting the right rule, really, right? So we can see it's working, but are we hitting the right rule? Sometimes you'll want to take a look at that and see which rule is being matched. All right, so now on router 1, again, we're going to be doing a named extended ACL. So let's get into global config. And this is where you're going to say IP access list. Now we precede it with IP because we're saying we're going to be giving this extended ACL a name. Now, we could give it a number here, and that would be to get in to typically do some modification to an existing ACL. However, here we're creating a net new ACL, and the name is going to be HTTP_only. So we're at the end of the activity there in terms of page length. And so we'll just work from here on out. So here's the ACL. And now you can see it's in the in ACL, which is where I could do named or numbered, right? And do a change to an ACL or create a net new ACL. So here we're just going to be permitting, right? So HTTP uses TCP and the source. Now we're doing the source network here, which is going to be that 172.22.34.96. Now, this is a /28, and here's where they show you the method that I would recommend, which makes it really easy or easier to figure out what would be the wildcard mask. Now, that is our source information. Now we need to get the destination information, and we're going to what host? 172.22.34.62. Excuse me. Now, again, when we have this, we're saying that all TCP traffic from that subnet is going to be allowed to go to that host. But remember, we only want it to be if it's HTTP traffic that's going to be going to that host. So here's where we put the equal down at the end of our ACL here. And so just like we did with the FTP, what would be HTTP? We could say 80, or we could just simply say www. Now, there's going to be another entry that we're going to put in here, and it's going to be for ICMP, very similar to the first one we did, 22.34.96. And we've got our wildcard mask in here again. And we're going to be going to the host 172.22.34.62. That's the destination address. So now if I say do show access lists, you can see we've got two ACLs here with multiple ACEs, access control entries, underneath each access control list. This is the one we just created, HTTP_only, which is allowing TCP traffic from that network to go to that host if and only if the destination port is 80. And down here, ICMP traffic can go from any host on that network segment right there to this host. And there's no port restrictions here, right? We're just allowing ICMP. Excuse me. So now we need to decide where to put the ACL. Well, again, extended ACLs, Cisco best practice, when applicable, put it as close to the source as possible. Well, we can base the source information off of which statement comes first in the ACLs, or the ACEs, the access control entries, and we know that this is the source network here. So on router 1, we're going to get into interface gigabit Ethernet 01, and we're going to say IP access group. And actually, before we do that, let's double check here. Let's see, does it even work right now? So let's go back to our desktop. Can I pull the web page up for the 172.22.34.62? And there it is, right? So the web page works right now, and that's good. Let me see, can I ping? Let's see if I can ping over to 172.22.34.66. Should I be able to ping the other PC? Remember, there's an ACL on this interface already that is saying unless the source is from this network coming into that interface for ICMP, it is not going to allow it, right? And so, and again, the source, and then going to the server for the destination. So this over here is not the server destination address. So we can't ping, which is good, and we get the web page, which is good. So we pull router 1 back up here. We say IP access group HTTP underscore only in the inbound direction. Again, traffic that is ingressing, right? Ingress traffic to router 1 on gigabit Ethernet 0.1. So let's go ahead and see now from here, can we ping the 172.22.34.62? Can I ping the web server? Absolutely. Now, just because I can ping it doesn't mean that I can get to the web page, right? Because we've got URLs. We have ACLs that are in play here. And so let's go ahead, 172.22.34.62. Can I get back to that web page and take a look at that? Works fantastic. So what do we want to do to check one last time? How about a show access lists? Whoops. And what are we looking for? We're looking for these matches right down here. Here's the ping, the 4 pings I sent earlier with the 4 matches, and then the HTTP traffic. We've got 18 matches. Again, remember, TCP, we're going to have 3-way handshake involved. There's going to be all kinds of HTTP codes flying back and forth. So we've got a few more messages there. And that really, it says from PC2, open a web browser. That works from PC2. It wants us to FTP to show that FTP will not work because we're not allowing FTP to the 172.22.34.62. And you can see we just get this sort of trying to connect, right? And so it should fail. Yeah, the connection should fail, right? And that's the last thing that we've got down here. You can see the activities at 100%, right? And so remember, a couple key takeaways from this activity. You can have named or numbered ACLs, right? And standard ACLs should be applied as close to the destination as possible, where extended ACLs should be applied as close to the source as possible. Again, when possible, right? Doesn't have to be that way. It's just when possible. All right, so that is going to do it for Packet Tracer Activity 26.2.1, where we took a look at extended IPv4 ACLs in Scenario 1, and now we're going to make our way into Scenario 2. Thanks so much for watching, and I hope to see you in the next video.